Hello everyone and welcome to my Java tutorial series. In this particular episode I'm going to be going over classes. Now classes are extremely important to any object-oriented language out there, not just Java or C++ or Python, but all of the object-oriented language. Without classes they wouldn't actually be object-oriented languages, they would just be scripting languages. But I'm not going to sit here and just talk to you about how classes can be useful and what they're good for before going into how to actually make them, which is what I would normally do to give you a full understanding of the subject matter before I just jump into it headstrong and you not understand why what the purpose of doing all I'm doing is and how they would be useful. But it's kind of hard to explain how classes and objects and stuff work without first showing you some code. So I'm just going to kind of jump into it and explain how they're used as we go through the process. Okay, so to start off here, you can see I've not got really anything special in this at all, but I want to print out to the screen the number of people this is just a variable called number of people, and this variable is in the tutorial class over here, and that number of people is 100. And just by the way, if you need to actually create a new class, you can use this button, just give it a name and give it a package, and then it'll create it in that package. So you can see I've got the two things here. Now you could technically not do it that way. You could just simply go outside of the braces for the current class and just do class and then the name of the class there and do it that way. But then it wouldn't be in the same file, and while it's not really that big of a deal, it's just for organizational purposes, it's good to keep each class its own file, because then if you come back from a while, you only have like 4 files, but you have like 20 classes. You'd have to be scrolling through each one of those files trying to figure out where all the classes are, right? So it's better to create a new class every time, like create a new Java file every time you want to create a new class. Though again, technically all you have to do is just go outside of these things here and just type class and then the name of it to do a new one. Anyway, back to what I was saying. I've got the tutorial class over here with this variable in it, and I need to get this variable into system.out.println. And the logical thing would be, okay, just copy and paste a variable, but in a practical world, you may have a class that's devoted entirely to getting input from the user. So maybe I arrived at having that number of the number of people from like a poll that is created in that class, and it does the poll and it figures out how many people there are total, and then I need to get that number from that class and put it in here, right? So how would I go about doing that? Because I can't simply type number of people. If I just type number of people, it's not going to work. It does not. And realistically, you wouldn't expect that to work because there's no number of people in this class. I mean, sure, there's one in another class, but there's all kinds of Java classes all over the place. JOptionPane, the math class, there's system.out, that's its own class. If it just simply started using variable names like that for just out of the blue, just because you have another class, you would run out of variable names rather quickly. So what you have to do is bring that class into memory in a way that the class you're currently working in can talk to it. So what I mean by that is doing this. New tutorial. So doing that is going to bring that class into existence. It's going to instantiate it, just like you would a variable of some sort. And the only reason it's not already in memory is because the program starts in public static void main. So the program starts there, and because main has that method in it, it's going to start in that class and not in any other class. If it went ahead and brought all of the classes associated with it into existence first of all, it wouldn't know quite where to stop bringing in classes, because there's all kinds of classes in Java that you haven't even seen. I mean, there's like literally hundreds of classes of Java, and just allowing you to do different things. The system class, for instance, printing out to a console. So if it went ahead and brought all of those into existence and in memory, your program would just crash, because there's just so much information bombarding it at one time. So what you have to do is manually tell it, okay, I want to bring this class into existence and start using it. Now, normally you would actually have to import things. Now, I don't know if I mentioned this in the past, but you don't have to import system, simply because it's already technically in the same package as whatever class it is or that you're working on currently. It's always in the same package, just because of the way Java is set up. And there's a few of them like that. But normally, for instance, for JOptionPane stuff, you would have to import that, java.awt. whatever, and then for the JOptionPane stuff, because you're having to tell it where to go to find that class. So unless it's in the same exact package as your class, you'll have to import it. Okay, so just keep that in mind. Now, that's the only reason I'm able to just type that like that and it work. Because tutorial is in the same package. So the package being like a folder, it's like if I were exploring my desktop and I double click on a folder, that folder would be a package, and then I could find the two files, main and tutorial, in there. So by default it just starts looking in the first package that it finds, and if it sees it, then fine. If it doesn't, then it gives you an error and you'll have to import it. Okay, so I can't do something like new pumpkin. It's going to give me an error because it can't find that. Okay, so just keep that in mind. Now, once I've got tutorial running and it's instantiated, what am I going to do then? This is still giving me an error. I mean, it's there. I've instantiated. It's brought it into memory. But the only problem is it's brought it into memory, but it doesn't know what to do then. Because you could have, let me actually show you an example of a class I made, right? So there's all of these variables, all of these stuff, all of methods, this is just one big giant method, and all this stuff. So it's not going to automatically know, just because there's all of this stuff in this class. So this is not going to just automatically know what it is that you want. You have to tell it, okay, I want this. But, how are we going to do that with this? We can't simply type tutorial, if we do tutorial dot number of people, that's not going to work. Now, the only reason that's not going to work is because when we type tutorial, it doesn't know what we're referring to. Yes, we brought the tutorial class into existence, but we can bring more than one tutorial class into existence. I could type this. Just do copy and paste. I do this 4 times. That's not going to be the same thing over and over again. Like if I were to do int, number equals 5 times, it wouldn't just be the same exact number being assigned to the same exact variable. That's going to be 4 different classes, all 4 of them separate from each other, all 4 of them technically having the exact same information, but each one, it would be like its own variable. So I have to figure out some way of naming one of them, really, so that I can get an ID to it, so that I can get information from it into it. Okay, so we need to treat it like a variable. So what I need to do is, let me just type it all out. Alright, now if I do... Now that works. Okay, so what did I do? Essentially, I treated this like a variable. The tutorial class is the name of the variable. Okay, let me write under this. Do int number equals 5. Let's do this. Okay, just so you can have comparison. Number is the name of the variable. Tutorial class is the name of the variable. Tutorial is the identifier. Int is the identifier. Okay, it's telling it what it is that we're going to be storing. Now, you would think that we would do class if we're going to be storing a class in there. But even if we typed class, it wouldn't know what class to be storing, because each class would, theoretically be different in information. So we just skip the class part and we just type the name of the class itself, because it's going to know that it's a class based off of the fact that we're just typing that word. So we're typing that word in, and it's going to look, and it's going to say, okay, well, this has to be a class. That's the only way this statement would make sense. So it looks for the class, it finds it, and then we're good to go. Okay, so we don't actually have to type the word class. And then equals new tutorial, and then in this case it's 5, because we're assigning it the value of 5. In this case, we're assigning it the value of tutorial. Now, if we were to try to get a separate class, like say we do pumpkin, like if I make a pumpkin class, and then I do pumpkin tutorial class equals new tutorial, that wouldn't work, because tutorial is not a valid thing that we can put in to a pumpkin variable. It's just like trying to put that into an int. I mean, yes, we can store I, but we can't store it in an int. So this seems kind of redundant, but you have to store tutorial classes in tutorial classes. I know that seems stupid, but that's just sort of the way you have to type it out. Okay, so once we have this variable as a reference point to tutorial, so that we can have something that we can say, okay, I want this version of that class, right? Just like, if we were making a variable, just, so we can get some sort of solid answer. If you want 5, you'd have to have something to store that 5 in. That's what we're doing. We essentially can then get number of people, because we can say, okay, tutorial class, I want this from you. Okay, that dot is what's getting this from you part. That dot is saying go into this class and get whatever it is that we type, and then we type number of people out. So it's, think of the dot like a folder, right? Tutorial class is the folder. We the dot would be like a double click. We double click on the folder, and then all the stuff inside tutorial class is available, and we just select the one that we want. Okay, that's sort of my analogy for you there. Okay, so once you have these variables for these classes, you can access methods, you can access whatever it is that you want through it that way. Now, let me actually write a method out just to show you what it would look like. If I do public int return people return number of people. And then if I did return people, that would work, because that's part of the class. So we can do a dot and then we get return people. So if I do this, you can see all that's inside this, right? We can see the method return people right there. We can see number of people there, and we can see a bunch of other methods in here too. All of those methods are inherently part of every class. It's like sort of the building blocks of what makes a class able to happen. It's all that background code. It's kind of hard to imagine background code behind the stuff that you write, but all of this stuff has to be converted into binary. So it's sort of like some stuff in the background that allows you just some extra functionality to a class, as well as background stuff needed to make it work. So anyway, you don't have to. 99% of the time, you're not going to need the rest of this stuff. You're just going to need the stuff that you write. So there's return people, which we could use. And then you can, so you could do it through a method if you wanted to. But that's all well and good, but I still don't really maybe you still don't understand why you would ever need these. I mean, sure, it would be nice. It's sort of a further way to organize all your code, but, what's the big deal? Well, think about what it is that you just did. You could have all kinds of information stored in that class and access it this way. So let's say you're making an RPG game. You have, your player is like a knight, and he's fighting a monster. The monster's a skeleton. Well, that skeleton is going to be its own class. You're not going to have the skeleton in the same, space of code that the player, like the player character is going to be, and the GUI is going to be, and all the floor, textures are going to be in. You're going to have it in its own class. That way, you can make as many of them as you want, because, again, I could make another tutorial class if I wanted to. All I have to do is do new tutorial. It won't have a name, but it'll make a new instantiation of it, right? It'll make a new version of it. So I could make as many skeletons as I want by simply doing that. And what the great thing is this is not really this is the part that's not really accomplishable in just doing it in one class, is each one could have its own health. So normally, if you wanted to do that, you would have to have the health of each individual skeleton, have to be a separate variable. In this case, all you have to do is simply make new classes. And instead of having to make new variables for each different health, you have a health for each skeleton. You just have one, and then you have all of the other information about that skeleton there, instead of having to duplicate all of that information for each skeleton you would want to do normally. Because otherwise, you would have to have health of skeleton 1, health of skeleton 2. Attack animation for skeleton 1, attack animation for skeleton 2. Or you could have one attack animation, and one health, and one all that other stuff, and then just make multiple versions of the class. So that's sort of an example of how that would work. It works well whenever you're doing GUI systems too, because each separate GUI system that pops up could be its own class. Each one with its complete buttons and all that stuff. And anytime you want to, launch a new GUI, you just simply create a new class. Right? So that's sort of another example of how that would work. I've actually, if I pull this up, you can see all of these are like buttons. So whenever I click on the calculator button, it clicks a new class for the calculator GUI, creates a new class for the color chooser GUI, it would create a new class for the timer GUI, and all that kind of stuff, right? And I don't actually need to have it be stored as a variable. I actually had created it a variable, but so it was like new. It was like calculator GUI. Calculator GUI class equals new calculator GUI. But that's pointless because I don't need to access anything in that class. All I need to do is run that class, and the code inside the class will do the rest for me, the way it's written. Okay, so just sort of keep that in mind as sort of how that works. But on to more in how classes themselves work. There are constructors in classes, which essentially what they do is it's sort of like a methods version. It's like the argument section of a method. If I go back over to here, I could actually stick something inside of this, if you remember stuff about methods, and I could stick like, int input, and then I would be able to I would send a number through whenever I, run that method, and it would give me that number, and I could do stuff with it. You can do the same thing with classes, except it's a little bit differently. It's done a little bit differently. All you need to do is at any point in the class, at any point at all, any point before you start making methods. I think it's before. Well, let's find out. I can find out if it's before methods or not. Okay, so no, it can really literally be anywhere in the class. You can actually set this up. Now, of course, just keep in mind it's going to run in order whenever the class is created. It's not going to jump down to the arguments section and start running from there. It's just going to run from top to bottom. Okay, but just you can stick, like, usually people will stick it right after they create all their variables, and then you write public tutorial parentheses, and inside the parentheses you put what it is you're accepting. So I could do int input, and then I can do number of people equals input, and I simply do this, and there we go. Oh, whoops. And so now what I can do, whenever I create this class, I pass it like something like 200. And now it's actually giving me an error because I have this constructor, and so essentially I have to pass it something or not. But here's the beauty of these constructors. You can have more than one. So I could actually do this, and then just have number people equals 0 and not have that at all. So it would be entirely possible for me to enter 200 and then not enter anything at all. And here's what will happen. Let me write 2 of these. And I'll need to give this one a name. So tutorial class 2 equals. So now if I run this, one's going to be 200, one's going to be 0. This first one, right, is 200 because I'm passing it 200. It's taking that 200 and storing it in number of people and then returning that. And then the second one, I didn't give it anything, so it's just setting the number of people to be 0 and then returning 0. So I could also I could flip-flop it. I could do this way. And if I do it now it's 0 and then 200. I could do that. And then I could pass it 0 if I wanted to. It'd still be 0. Okay, so that's just sort of how constructors work. And you can make as many of them as you want. The only thing you want to keep in mind is you want, if you're going to do this where you're like setting things equal to things in the constructors, you need to make sure that you initialize your variables before you do that. Because if you try to do this, it's going to dislike you a lot. Because essentially now, while this would technically work, and it works for that one, this also, it can't find this integer because this integer is being created here and it has to do with scope, which I'll talk about more in depth in a future video. But it can't see this because it's between these two. That's when it's first created. So it can't see it because it's like in its own section. So this can't jump into here. It can only, the way, in short, without going in too deep, scope is sort of, it trickles down, but it doesn't trickle up. So it's like a creek. You can see down creek. You can paddle down creek easily, or down a river, but it's harder going up creek. Like if you pass an offshoot of the creek, you can't go back up the creek and then down a side chute and then go back up the side chute and down the river very easily. Essentially, you can't do that at all in here, so it can't go up to the class and then into here to see the variable. You have to have it into here and then it go down into here. Okay, hopefully that makes sense. Again, I'll be discussing scope more in detail in a later video, but we have to have the variable be declared outside of the constructors. So if you know, a lot of the time, actually, if I go back into here, one of these, you can see I have a whole bunch of variables being declared right here. And a lot of them are finals. This one is not, and all of these don't have anything being assigned to them. They're just simply being declared. And then in the actual constructor itself, I'm actually setting them equal to things, you see. So that's sort of what you usually end up doing, is setting a whole bunch of stuff equal to things in the constructors, because the constructors are guaranteed to run whenever the class is created. So, sometimes you have different constructors. Sometimes you just have one constructor, which is the empty one. You don't pass it anything. It's entirely up to you on what you want to add, but you can add as many different constructors as you want. You could actually add a constructor for, one having input, one having an int and a double, one having an int, one having a double, one having a double then an int. Whatever order that you decide to choose, you can have as many of them as you want. So, anyway, moving on to the couple different keywords that are available. I didn't talk about public or static keywords in the last thing because I said it would be easier to discuss with classes. And it is much easier to discuss with classes. If I were to take this and not make it public but make it private, I would get an error here. I should. Oh, I spelled it wrong. There. I get an error there. Now, why is that? Essentially, making something private is making it so other classes can't access that method or that variable or something like that, right? If I go back in here, you can see all of these variables are set to private because I only need them for this class and that class alone. I don't want any other things to access it. So if I make this method private, then what happens? Okay, why that just happened, I don't know. Okay, back to normal, please. So in here, I can't access that because it's sort of like locked out to me, right? I don't have the key. Only the class that owns it has the key. Now, the only reason you would want to do this is really to sort of prevent yourself from making mistakes. It's sort of like making something a constant. It's only really there to prevent you from accidentally making changes to it or something like that, or using the wrong thing. And in a way, it's helpful in some cases because maybe some methods you don't want you're never going to really need except from one class, so you just block it out to all the other classes so you don't have it cluttering up stuff. But it can be incredibly useful whenever you're doing group projects with other people. So whenever in your code you only allow like maybe one or two methods, only the methods that are needed to be public. That way people don't accidentally type in the wrong thing and cause an issue. Because you can see it causes an error in this class, even though it's an actual method. It just causes an error. So you could, if you are working with other people and you're working on a method, you make the method private or public depending on whether or not they're going to need it. If they're not going to need it, you write it public. You're private. That way, if they accidentally type in the method that you're working on, it's going to give them an error, and they can say, oh, whoops, I typed it in wrong, and move on, rather than giving it a positive and continuing. And again, that's just sort of a, not that it'll happen too often, but, it could possibly happen, so it's there. And it's a feature that's there, really, just because of the way Java was designed. It's to prevent user error. And a lot of Java programs are fairly stable, and bug-free, simply fairly. I say that, and I kind of laugh. I mean, there are a lot of problems with, some Java programs, but on average would be a lot less than, C++ stuff, simply because it tries to block out as many user errors as possible by doing stuff like this. So there's public, there's private, and then there's protected, which is even more secure than private. Like, it's to the point that even stuff in the own class, some things can't even access it, right? So that's rarely needed. And then there's actually nothing at all. If you don't type public or private or protected, it's sort of a cross between public and private, where anything in the package can freely access it, but anything outside of the package cannot. So it's sort of like a cross between the two. It's weird, and most people don't end up using that one. It's just either public or private. They're the two that are most widely used. So, when on methods you can type public or private, or again, you don't have to type anything really, but it's just that weird version. And then classes, you have public, private, and you can actually add it to variables too. So I could do public int. Now, again, it's not necessary. I was able to access it, but outside of this package, maybe I have other packages, for other things. I wouldn't be able to access that variable normally unless I added the public keyword. So, there's that. Now, static. Static can be a confusing one, but it's a very useful one. Main is static simply because it has to be, it has to be because of the reason for what static does. But the static keyword, when applied to classes or methods or even variables themselves, makes it so there can be only one instance of that. Now, what does that mean? Only one instance. You just said I could make multiple instances of classes. Well, yes, that's true. But let's say, let me try to write this out real quick. Okay, so if I do public int number of classes, and then in this one we get number of classes plus. I gotta make this static. Notice first of all that it goes to italicized, and it's italicized down here. Okay, so what this is going to do is every time I make, let me also add it to this one too. So pretty much every time I make one of these classes, it's going to increase the number of classes variable. Let's just see what happens. Okay, so I'm going to print out tutorial. No, I don't know what I'm thinking. Classes. Control C. Control V. 2, 2. Now it says 2 both times. Okay, now let me try rearranging this and show you something different this time. So I'm going to rearrange this, and it's going to be 1, 2. Now if I just sit here and I do new tutorial, like a couple times, 1, 6. 1, 2, 3, 4, 5, 6. 6. Okay, so every time I created a class, it added 1 to that variable. But here's the thing. Earlier I said that each class has its own set of attributes and stuff, right? But a static has only one instance. That's what static does. It makes it have only one instance. So the static keyword made that one variable only have one shared between all of the classes. So every time a new class got created, it was making that constructor and it was just adding to it. It wasn't changing it. I can't physically just change that number. I can't actually go down here and just go number of classes plus. Right? It's not going to let me, because that would be violating the whole point of having a static method. The only thing you can do, or a static variable, The only thing you can do is stick it in a constructor like that and have it increase like that. You know, maybe stick it in a method or something and increase it like that. But they're very good for like keeping track of like the number of classes you have total. For instance, if I go back to that RPG example, you have you're creating a bunch of skeletons, and you could just create them this way, right? You don't have to give them names for each one, but then you would want to keep track of how many skeletons there are total, right? Just, so you would have something keeping track of the number of them that you could possibly display on the screen or something, if you need to do that for like a goal, kill 8 of them, and then every time they kill one, it subtracts that, right? So you could do that. There's our uses for that sort of thing. But not only can you do the static variables, you can do static methods. So like if you need a method that's going to work the exact same way for each class, you can do that. Now, how would that work, you'd be thinking? Well, let's, if you have a method that like adds 2 numbers, right? So you have to pass it 2 numbers. Well, if you have a utility method, usually utility classes, like a utility class would be something that doesn't really do anything except house a bunch of methods that are going to be used for like random things. So for instance, I actually have a utility class in this other program over here. So there's a calculate method, and there's a isPrime method, and there's a timer method, which doesn't have anything in it at the moment. So there's several different methods I have in here. And they're all static because I only want them to be available, and they're going to be available for every instantiation of utility, and it's going to be the same. You're not going to be able to like change any of the numbers involved. Whatever you get is going to be the exact same, just like a regular variable, except it's on a method scale. Because if you have multiple instantiations of something, if I go back to the skeleton example, different skeletons are going to have different health values depending on how much you've killed them. So if you perform math on them to say get the health of the skeleton, that would be a method that you wouldn't want to be static, because the answer is going to be different depending on each class that is there. But what you would want to be the same is like the method for get name. The name's going to be skeleton for every single class, so that would be something that you want to have static, because that's going to remain the same for each one. It's not going to change. So hopefully that makes sense of why you would want some of them static and why some of them not. Now, one thing that you do have to consider, if something is static, you have to, if it's referencing something else, like if a static variable is trying to make itself equal to another variable, like over here. If I tried to do number of classes equals input, it wouldn't work. Because, well, would it work? I guess it would work. Didn't expect that to work. Well, usually things that are static cannot reference things. Oh, no, I'm sorry. It's the other way around. It's this that I can't do. Or, no, I can do that. Crap. Okay. Well, you have to be careful whenever you're using static, because sometimes they can't reference things that are non-static simply because of the way that the static works. So you can't like reference something that would be different for every single thing, thereby giving you a different answer every single time, right? In this case, I guess it's not mattering for whatever reason. I didn't think that was supposed to work, but it is, because reasons, and it's making me look like a fool. But I know, like sometimes whenever you're doing stuff in main, sometimes you have to like make things static simply because of the fact that you're in a static method, and you can't reference non-static. If you get something saying you can't, like an error saying you can't reference a non-static member, you have to make it static, because you can't reference something which would thereby make it not be static simply by making it equal to that. I can't think of an example off the top of my head that would give me that error, but once you run across that error, you'll understand the context and of why it's going on, as long as you understand what static is. Now, static classes essentially are not used very often, but what they would do is, let's say that you have a class. Like in this class right now, I've created several instances of tutorial. But let's say in another class, I've actually created several instances of main. Well, because of the way classes work, if I created an instance of main, it would then go through all of this code and it would create instances of tutorial. So, let's see. Let's get it down to this. So I would have 3 instances of tutorial right now. If I created another instance of main, I would then have 6 instances of tutorial, 2 instances of main. Does that make sense? Hopefully. If tutorial was static, what would happen is, while I may have 6 technical instances, if I edited one thing in one of the classes, they would all change. Okay, because just like the variable of, before and the static methods, you can only have one of them. So I could have multiple instances, but they would all be affected if I changed just one. So even if I had 6 of them, if I changed one, they would all be affected. I could only have one of them. I could only have a certain number of them per main class. I don't think it would. Let me just make this static, because I don't think it'll actually let you have 6 of them. No. Doesn't even let you set the class as being static. So that's not even a thing you would have to worry about. So never mind. I don't know what I'm thinking about. I do think, though. Yeah, okay, so you can't even do that. So never mind. Okay, so that pretty much covers all there is to do with that. With classes. Yeah, I can't think of anything else that would be relevant to talking about classes. So hopefully that was, you understand how they work now. I have literally tried recording this tutorial probably a good 12 times, because I would not explain something correctly. So if you have any questions, feel free to ask, because I don't mind answering questions or just redoing something, if I didn't explain something well enough, because I've redone this tutorial so many times. I just can't do it again, because it wouldn't be any good anymore, because I'm so done with doing the same thing over and over again. So just let me know what you thought. That would be appreciated, so I know if I'm doing well or not, and ideas for future tutorials are always good. Anyway, that's about it. I leave you now, and I will see you in another video. Goodbye.